Welcome to next lesson in relativity. In this class, we will discuss the examples of mass-energy relation. In the last class, we have derived the relation between mass and energy, and we found that it is one of the important relationship obtained from the special theory of relativity. An amount of energy E is equivalent to an amount of mass m by the relation E is equal to mc square. An amount of mass m can be converted to energy. The energy released will be mc square. And this is the mass energy relation. It shows the equivalence between mass and energy, and it shows that mass can be converted into energy and energy can be converted into mass. So there are many examples for this conversion of mass and energy. Here we will discuss some of the examples. First one is the electron-positron annihilation and pair production. First we will discuss the electron-positron annihilation. Positron is an elementary particle which has the same mass as that of the electron but with the opposite charge. This positron is considered as the antiparticle of electron. For every particle there is an antiparticle which will have opposite mass which will have opposite charge with the same mass. So when an electron and positron come together, they will annihilate, they will combine together and they will disappear with the production of two gamma rays. Gamma rays means electromagnetic radiation, that is two photons are created. The equation representing this process is a positron plus an electron gives two gamma rays or two photons. This process in which an electron and positron combines together and annihilates to produce a pair of photons is called a pair annihilation. Pair means electron and positron is taken as a pair. The electron-positron pair annihilates, and this is an example in which an amount of mass is converted into energy. Also, the reverse process is also possible. If a photon of enough energy in the presence of a heavy nucleus, because the presence of a heavy nucleus is required to conserve the momentum in the process. So, a photon having enough amount of energy can disappear producing an electron-positron pair. That is, a photon gamma gives an positron plus an electron. This process is called pair production. So pair production is an example in which an amount of energy is converted into mass. So these two processes, pair annihilation and pair production, reveals that energy can be converted into mass and mass into energy. They are interrelated. Now, to occur the pair production, the energy of the photon must be greater than the combined rest energies of electron and positron, because we know that when an electron is produced, its energy minimum energy will be equal to the rest energy. The rest energy of electron is 0.512 MeV. So to produce an electron and a positron having equal energies, we will require a minimum of energy 1.024 MeV. So the photon producing pair production should have an energy greater than this value. This is the critical value for the pair production, and photon having this much amount of energy comes under the gamma ray spectrum of the electromagnetic radiation. Another example for the conversion of mass into energy is the nuclear energy. We know that nuclear fission and fusion release a large amount of energy. This is also due to the conversion of mass into energy. An example is the fission. A typical example of nuclear fission of uranium-235 is shown here. When a uranium-235 nucleus is collided with a slow neutron, it will fragment into different pieces, and there are different possibilities. One of the possibility is shown here. It is 56 barium 144 and that plus 36 krypton 89 plus 3 neutrons plus a large amount of energy is also released. And what is the source of this large amount of energy? If we calculate the mass of the reactants, we will get the mass of the uranium-235 in AMU plus mass of the neutron in AMU. It gives 236 AMU. And also the mass of the products, the mass of barium, it is 143.87, then mass of krypton, it is 88.9, plus mass of the 3 neutron, it is 3 into 1.01, it will be 235.8 AMU. So we see that the mass of the reactants is greater than the mass of the products. So during nuclear fission, a certain amount of mass is lost, and the loss in mass delta M is equal to 236 minus 235.8. It is equal to 0.2 AMU. AMU means atomic mass unit. So this much amount of mass is converted into energy, and the energy released will be delta E is equal to delta M into C square. That is equal to 0.2 into 931 MeV, because this 931 comes by the fact that 1 AMU is corresponding to 931 MeV. And AMU means 1 AMU means 1.66 into 10 raised to minus 27 kilogram. You can convert that 1.66 into 10 raised to minus 27 kilogram by using mc square into joule, and that joule can be converted to electron volt, and then it is into mega electron volt. So you will get the 931. So simply you remember that 1 AMU corresponds to 931 MeV. So 0.2 AMU corresponds to 0.2 into 931 MeV. So we will get almost equal to 190 MeV. So this much amount of energy is released from the fission of a single uranium-235 nucleus. Remember that in a sample of uranium-235 there will be a large number of uranium-235 nuclei. So from that sample a large amount of energy will be released, and this is the origin of nuclear energy. It is the conversion of mass into energy. In nuclear fusion also, the mass of the products will be less than the mass of the reactants. In that case also, the mass difference is converted into energy, and it will be released as the energy of the nuclear fusion. And 1 AMU, it is the conversion of 1 AMU into MeV. 1 AMU is 1.6666 into 10 raised to minus 27 kilogram. So the corresponding energy is mc square. You will get 1.49 into 10 raised to minus 10 joule, and it can be converted into MeV. So you will get the answer as this one. So thank you for watching this video.